what we're going to talk about today is how part of figuring out this mystery is finding explanations for things that are previously don't have explanations or inexplicable, and putting them together and not just looking at individual parts of it and saying, well, that's weird, but seeing how it ties into the big picture. So we are returning to the episode 10 topic of the potential for hacking and general bad stuff that would have allowed this plane to be hijacked by someone other than the pilot. And for that, you spoke to Ken Munro. This guy is fascinating. He's a founder of Pen Test Partners in the UK. And tell me about this guy a little bit, and then we'll jump into the interview.
Yeah, I mean, I reached out to him because partly as a result of MH370, I've been very fascinated by the ongoing effects of things like GPS hacking on commercial aviation, the possibility that, could autopilots be remotely hacked. There had been a dramatic increase in GPS spoofing of airplanes in such a way that these planes would be flying along and they would start to drift off course because the GPS was being spoofed. And this, of course, was very interesting to me as someone who'd spent a lot of time thinking about meddling with airplanes and spoofing. So I reached out to a number of cybersecurity experts who focus on aviation, one of the first being Ken Munro. Ken is the founder of this company called Pen Test Partners. That's short for penetration test, meaning they're basically white hat hackers. They try to think about how would a bad guy get into a system to take advantage of it.
But they don't go out there and just tell everybody. They give them a chance to fix it.
Exactly. I'm fascinated by people like this because they have to think like a bad guy, but be a good guy. One of the problems of trying to find vulnerabilities in airplanes is that unlike an iPhone or a modem or something, which you can just go buy at Best Buy, you can't just buy a plane. What he managed to do is during COVID, when a lot of planes weren't flying, he went to a company that had one, a 747 in this case, and he said, if I pay for the aviation fuel to run the generator, can I play with your system? And they're like, sure. So he went in and he found some interesting vulnerabilities. He'll talk about that in the interview. But, it's one thing to come up with what looks to your eye as a layman as a potential vulnerability. It's another thing to take it to a professional and say, hey, guy who looks for vulnerabilities, is this a vulnerability? Is this a way that this plane could have been spoofed? And Ken very generously agreed to look. I wrote up a précis. I wrote up a description of how this whole process would work. And he looked at it and, well, you'll see what he thought. Ken, you are one of the foremost experts in, I would say, aviation cybersecurity. Would you say that?
Yeah, we've certainly got a very strong interest in aviation cyber. So my background, my team's background, we're penetration testers, so ethical hackers.
Okay.
And one of the things that the kind of COVID changed, a lot of airplanes got retired early. And that meant that the breakers yards got backed up. So we got to go and do some brand new vanilla research, learning how to hack airplanes.
Yeah, so I had talked to you for an article for New York Magazine about kind of the vulnerabilities that exist in cybersecurity. People are probably have heard about various state actors, Chinese, Russia, even the United States, are sort of probing the weaknesses of their potential adversaries' infrastructure. We tend to think of hacking as classically like breaking into the server and stealing the secret plans, or just like hacking people's bank accounts and stealing their money. But there's like lots of different ways you can exploit weaknesses.
Yeah, I mean, you have to think of hacking groups as organized now. I know of hacking groups which have got an HR function in them. We have to think about money. It's what is the quickest route for attacker group X to make money? And that might be ransomware, holding an organization ransom, or it might be just doing something more insidious.
I mean, we had the case here in the United States in the run up to the 2016 election. We had this Russian military intelligence link group breaking into the DNC, the Democratic National Committee, and stealing emails and releasing them and causing all kinds of chaos. So you can have various motives.
Yeah, hell yeah. I mean, it's, again, follow the money, follow the nation states. You know,
Right.
there's always someone with an interest in causing chaos somewhere, whether it's trying to influence the outcome of election,
Right.
or maybe it's trying to destabilize civil society by, for example, causing power cuts, which we saw happen in the Ukraine as the hostilities with Russia started kicking off.
Right. And so your specialty, your focus is aviation. So you do something called penetration testing, right? Your company is called Pen Test Partners, which means
Yep.
penetration tests, meaning you're sort of imagining yourself as a black hat. You're trying to think, well, if I was the bad guy, what would I do? Because of COVID, there were some planes that weren't being used. You were able to get access to one, and you were able to kind of play with it. And what
Yeah.
did you find?
Most times, you know, our history was industrial controllers, IoT, which you can go and buy off eBay and Amazon. So you can easily get hold of the hardware components to play with. Unfortunately, you can't do that with an airplane, right? You know, those 747s are a bit expensive to buy on eBay, right? So COVID changed things. The breakers yards, they got backed up, and we picked up the phone and said, look, hey, you know, that airplane that landed 2 days ago, is it going anywhere again? They said, no. So if we pay you for the jet fuel for the APU, can we power it up and come and investigate? And we found all sorts of really interesting things. First and most importantly is, as we suspected, you can't just hack an airplane from a seating coach, right? It doesn't work like that. So hopefully that will reassure the traveling public that you can't just sit there with a laptop and take control. No, it just doesn't work like that. Yeah, what we did start discovering were, as the plane becomes more connected, some of the data feeds, some of the systems that pilots use, that's where there was opportunity to start tampering with data. And a good example of that we talked about briefly was the idea of an electronic flight bag. So an EFB, that's a tablet. It's a Windows tablet, an Android tablet, and an iPad, which runs a suite of apps that help the pilots navigate. It helps them land. It helps them understand how much power to use on takeoff, and it helps them understand the weight of the balance of the airplane and lots of other things. Does it really efficiently, but we found some bugs in some of the apps that those EFBs use that could, in certain edge cases, be used to spit the wrong information out to the pilot.
Right.
But of course, we're ethical. We're the responsible people. We're the white hats, if you like. So if we find things, we talk to the manufacturers first, talk to the airlines first, and say, hey, we found something interesting. What do you think? And there's a great case in point with a vulnerability we found in a Boeing electronic flight bag tool called OPT. And we told Boeing about it. And they were like, hey, thanks. Hey, come and talk to us about it. And over a period of about 18 months, that got fixed. And they were super responsible. And hats off to Boeing. They did a really good job of dealing with that bug.
Well, that's a nice thing to hear about a company that has not had a lot of things nice said about it lately. But it seems to me that in cybersecurity in general, you kind of have to, if you're, or just probably security in general, if you want to be safe, you have to have some imagination, and you have to say, let's think about the broadest possible range of things that could happen. And then, don't just say, well, I assume my attacker isn't smart enough to take advantage of this thing. You kind of have to be open to possibilities.
And that's a really good point. I mean, it's back to Sherlock Holmes, isn't it? You eliminate the impossible, and the plausible, however improbable, I think that's the quote, has to be the truth. I guess one of my big concerns is about things is we talk about the Swiss cheese in the aviation model. I talk about that. I guess the nature of safety in aviation is they're always looking for the holes, fixing them before they become problems. We also talk about these cascades, these chains of events, and you often see something goes wrong, something else goes wrong, someone's tired, but plane doesn't crash because the cascade stops. And when you look at a genuine safety case where something's gone wrong with an airplane, maybe it's it's struck its tail or gone off the runway, or God forbid had a crash. Actually, it's that line of Swiss cheese, holes in the Swiss cheese. It's really, really interesting.
I talked about it a little bit before, but I think it's worth emphasizing that I interviewed this guy for New York Magazine because I really believe that this is a topic that's just starting to be important, but it's going to be massive in the years to come, especially as aviation gets automated increasingly. There's going to be an attempt to move from 2-person cockpits to 1-person cockpits. You might even see unmanned flight. And as things get more and more automated, there's going to be more and more opportunities for hacking and mayhem. And those trade-offs are going to become very important. And so guys like Ken, I feel like, are really on the cutting edge. So after I interviewed Ken for New York Magazine, I reached out to him and I said, listen, I've been working on this theory since 2014.
Yeah.
I would love to get your professional opinion as to whether there's any validity to it or even possible validity to it. And he agreed to take a look. So I sent it to him, and this is what he had to say. Ken, let's get to the meat of the matter. So you've been very generous you agreed to look at this idea that I had been working on with the help of some other people, notably Victor Iannello. And this idea is to sort of ask, in the spirit of like, what is the outer envelope of things that we should be able to consider? Was MH370 potentially, did it possess potentially a security vulnerability? Now, I really want to emphasize, this is not to say that it was taken advantage of, but I think that for the exercise of today is to say, is it conceivable that this vulnerability existed? Because we're starting to get into an era where, as you say, things are more integrated and we should be more and more aware of cybersecurity vulnerabilities. So I sent you this document that basically wrote up this like long, kind of fairly complicated idea. And you were generous enough to look at it. And so what were your sort of overall thoughts?
So I thought it was a really well-written document, I'll be honest with you. So one of my colleagues who is very skilled in aviation and aeronautics, he looked at it and said, it's a plausible document. Technically, it stacks up.
Okay.
The discussion point that was made, I think we'd say it's plausible. Okay. Is it probable? And that's the bit where I'm struggling actually. Is not only that bit, but also the other bits of the Swiss cheese that had to line up as well to make that theory plausible.
Okay. Maybe we could start just by talking about sort of the gist of what we're getting at here and why it might be possible to carry it out. And then I also definitely want to talk about why you think it was not carried out. But so maybe I could start just by sort of recapping a bit. The idea is that the location of the plane as determined by the Australian investigators was based on subtle changes in frequency that were generated. If you're interested in this, you're going to have to like read a whole other thing because it's quite long, but it has to do with changes in the frequency that were generated by an algorithm within this particular piece of equipment called the satellite data unit, which is physically located above the economy class cabin in a 777. And you can access it by opening up the ceiling panel, and the box is there. There's a plug in the front called the PDL, and you can plug a box into it that maintenance crews use to update the software. Yep. And if you were to change a parameter it's called the systems table, and this is one of basically the variables that the algorithm uses to calculate the frequency at which it broadcasts. And so the sort of the nut of the question that I was asking you, Ken, is it possible that somebody on board the plane in flight could get in there, plug into this box, and change that parameter so that they could alter the transmission frequency, potentially thereby altering the data that the investigators would ultimately get and use to calculate the search area? Super complicated, pretty arcane, but the question is like, okay, should this be included in the list of things that are within the outermost perimeter of what's conceivable?
Yeah, so I spent quite a bit of time looking at some of the findings in the documentary that you're involved in, which was fascinating. There were bits of me that I got quite frustrated, but I thought it was absolutely fascinating to go into some more detail of why we felt some of those things couldn't work. Now, first of all, the SDU, the SATCOM terminal, it's in the overhead in the passenger cabin in a 777, I believe. It's quite unusual because most of the devices, the avionics, if you will, are actually in the avionics bay. Remarkably, the SATCOM terminal in an older 747 is in the same sort of place. It's right up. You're going to need a big ladder to get up there, though. You're going to have to
under the antenna is the reason it's there.
Yeah. So you've got to firstly, you've got a physical access problem. So you're going to need a step ladder.
Okay.
So you're going to have to unmount the ceiling panels, which are actually quite easy to do. I don't recommend anyone tries it in the air, but they're
Please
actually
don't
quite
do
easy
this.
to unmount. Yeah.
The cabin crew will not be happy.
Yeah, and I've got photographs of us on a 747 at the top of a step ladder, actually looking at the SDU.
Oh, wow.
And we were at the top of it must have been a 12-foot step ladder. So you've got a physical access problem to start with. It's
Okay.
not easy to get up there, right?
Okay.
But yeah, there are interfaces up there. Now I've actually brought along an example. So this is what's called a line replaceable unit. So this it's not an SDU. This is actually a radio altimeter or a radalt. Now these things sit in great racks in the avionics bay, and the SDU doesn't look that dissimilar to this. They often look a bit more like they're on the side. But as you can see, there's lots and lots of interfaces here. So in the case of a radalt, that'll go to a receiver, an antenna, and then lots of other interfaces with the aircraft systems. Now, the SDU.
Wait. Before, just to clarify, so it's called a line replaceable unit because, kind of as the name implies, you can pull it out and replace the whole thing. You don't have to take the entire airplane apart, and
it helps dispatch. So these sit in great big racks in the avionics bay, the EE bay. If you go onto any search engine, you'll look for a picture of an electronics bay, you'll see racks of these. And the reason they're called line replaceable is if there's a fault or something's not behaving easily, it's very, very easy for the maintenance engineer to just pull this one out, put another one in, send this off to the shop, and then the airplane's going again. So line replaceable, it means our planes go more frequently without getting faults.
Got it. And it's located, this particular kind is unlike the SDU, is located in the electronics bay, which in a 777 is towards the front of the plane. There's a hatch at the front of the first class cabin near the galley.
Yeah, that's right. It's quite unusual, the 777. It's like the 747. So almost all avionics bay access. So in the short haul planes, it's going to be external. There's no internal door. Modern long haul airliners, the avionics bay hatch is typically inside the cockpit. However, the 777 and the 747, there is a door in the forward area that will take you down to the main avionics bay.
So that's a line replaceable unit. But of course, what we're talking about is not there. I think you were starting to say. I cut you off.
So
and I just
typically what we're looking for. So the satellite data unit, again, I know more about them on the 747 than I do on the 777. There are interfaces, and I've got some other LRUs around which do have interfaces on them. This, for example, has a troubleshooting port. It's actually what looks like an old RS-232 port, but anyway. Here's the thing, though. So PDL, that stands for the portable data loader. So that's the way that maintenance engineers update the software on these LRUs. So sometimes it's a direct connection, but most times it's going to be an interface in the avionics bay where they can connect a ruggedized laptop, probably in a Peli case, plug it in. With weight on wheels, they can then apply software updates or software fixes to the line replaceable units. So they get their latest updates and everything's nice and good and secure and fine.
Ken brings up a topic in that last interview where he's talking about weight on wheels. I know what that is. That basically means that stuff only happens when the plane is in its parked or on ground configuration, right?
Yeah, there's things that the plane really should not do unless there's weight on the wheels of the plane. A really obvious one is like a thrust reverser. This is where the engines, instead of pushing the air back, they push the air forward, and it slows you down really, really fast. If you do that in air, you're screwed. Okay, so you can only do thrust reversal if there's weight on wheels. But another thing you can't do, as Ken talks about, is you can't update a lot of these systems. You can't reprogram the computers in mid-flight. You have to be on the ground, in between loading up passengers and everything like this. The system is designed so you can't screw around with it in flight. The point is just being like, if you're trying to do something that the plane will only let you do with weight on wheels, it makes it a lot more complicated. Not necessarily impossible, but a lot more complicated if you have to have weight on wheels.
It should be impossible to push a software update to an LRU without weight on wheels. By that, I mean the airplane's on the ground, it's not flying, therefore it's much safer to apply software updates. Now, this is one of the issues I had with the Netflix piece, is that one shouldn't be able to simply push new software. But we gave it a bit more thought. And of course, actually, there are chipsets inside here. And arguably, you could unmount those chips. You could clip programmers onto them. And in theory, stretching the bounds of reality a bit, after dismantling this, you could, in theory, reprogram parts of it that might meet the criteria to cause that misreporting of the satellite position.
Okay, wow.
But that's really, really involved, right?
Yeah.
So you've got to get there, get it down, get it into pieces, know it inside out, be able to connect to it, be able to provide the required credentials that it might need to reprogram it, to tell it to do something different. That's a big job. That's a very high skill exercise.
Okay. So even if you have physical access to the box, you've got your step ladder, you've taken out the panel, you've plugged in your PDL, you can't do a software update without weight on wheels. Even
you shouldn't be able to.
Okay. What can you spoof a weight on wheels signal?
Potentially. It might be possible. And again, it's an electrical signal. That's come from transducers on the undercarriage, but again, it's another layer of complexity. It's another hole in the many layers of Swiss cheese to make the stack.
Right. Okay. So, I mean, the thing is, even asking the question, we're so far out in the fringes of like what is, conceivable to most. And frankly, I have asked the scientists at Inmarsat who did the analysis of these signals that allowed them to determine where the plane went. I asked them if they had considered the possibility that these signals had been tampered with.
And I will come back to the same comment we made previously. And even with hindsight now, you can see that whoever did that would have to have 6 months worth of knowledge of what would happen. They'd have to know how data would be used, things that involved, everything like that. And there's nothing to show that evidence at all, as far as I'm aware.
Again, when we're talking about the fringes of what is possible and what is not possible, if we begin the exercise by saying, okay, let's let our imaginations run wild and imagine a like almost infinitely sophisticated and clever and ruthless whatever opponent, you have to imagine, like, as I said, almost unthinkable motivation and resources, etc. But so you're saying that you don't really know, but it seems unlikely that you could do it through the PDL. You probably would have to take the box apart. But I think, getting back to this idea we mooted before, Ken, which is that if you have physical access to an electronic component, and as I say, like unlimited cleverness and resources, you can make it do anything it's capable of doing.
Arguably. I mean, what we should be doing, there's many things you take from doing IoT devices, doing hardware, is it shouldn't be possible to cause the device to do other things. We shouldn't be able to push new firmware to it to cause it to do something else, because it should be cryptographically protected. So without providing a cryptographic password or checksum, it shouldn't be possible to be able to unlock the chips in order to get them to do something else. Again, that's kind of right up to date. And the sort of LRUs that you'll find in a 20-year-old airplane, they don't reflect state-of-the-art hardware security. We're going back in time here. And even the most modern LRUs on an airplane, they were probably designed 5 years ago, even on planes that are coming off the line brand new right now.
Well, the MCS 6000, which is the particular model of STU that was involved here, was itself already obsolete by the time that this flight took place. And so it's even hard to find proper documentation about it.
Yeah.
So that's interesting. But Ken, I did want to ask you about you talked about the Swiss cheese of improbability. Like, so we already talked about the ladder. We already talked about the necessity of like actually probably taking the box apart. Were there other things that you just felt like that sort of you would include in the set of things that would kind of Swiss cheese?
Yeah. So one of the other big areas of the Swiss cheese that really, really bothers me is I kind of think it was the wrong plane. And this might seem a really odd piece, but the 777 is quite an unusual airplane. So back in the day, so the 737, the A320, they all use an older network protocol called ARINC 429, which has been around since the dawn of time. But the 777 was different. One of the problems with ARINC 429 is it's not really a network as such. It's a series of point-to-point cable connections, which is great, but it means you need a lot of wiring. So the 777 came out with a new protocol called ARINC69, which is actually an inductively coupled network. And the result, it means you ran a series of bus cables around and you clamp onto them inductively. And this is actually a genuine inductive coupler from a 777. And so rather than have cables going everywhere, you had a network which inductively coupled through here. Okay. And it meant that you could save miles of cables, so therefore much more weight. Your plane was more efficient, less carbon dioxide. So that was really cool. But ARINC69 is much more challenging to decode and inject as a protocol. So ARINC49, relatively straightforward. So even a simple tool like a picoscope, which is like a $500 piece of kit, can decode, and it's not too much harder to then inject, although there are timing issues. 69, different matter. You need much more expensive custom hardware, like just the decoder's $30,000.
Wow.
So it means you've got yet another layer of complexity that's required. So first of all, you've got to get the SDU. You've got to take it apart. You've got to reprogram it, which is a challenge, believe me. And then you've got another one. If you want to, as was mooted, control the airplane from the avionics bay using a laptop, you've then got to now re-interface with a whole different network that isn't as well known and is much harder to connect to.
So Andy, what I had reached out to Ken to talk about was the question of, could this BFO data be hacked? Could it be spoofed?
Of course.
I hadn't really intended to talk to him about another issue, which had always seemed to me kind of a downstream issue. Like, first of all, can you hack the data to make it look like the plane went south when it really went north? But secondarily, there would arise this issue. Okay, if you did that, how would you then also take the plane somewhere else? And there's a real problem in the idea of like breaking into the cockpit in time for that turn at Agari without the pilots, radioing for help or anything like that. And so the idea that I described in my book, The Taking of MH370, was this idea that since the 777 was Boeing's first all-electric plane, it was the first plane that Boeing made that all the flight services were controlled by these computers in the electronics bay. So if you got into the electronics bay, would it be possible to hijack the flight control surfaces of this plane? And I hadn't really intended to talk to Ken about it. Parenthetically, so in the Netflix documentary, Mike Exner says, in no uncertain terms, you cannot do this. Also, in the famous Atlantic article that William Langewiesche did, he actually says something like, there's so many reasons why you can't do this that I won't even go into them. Right?
I love that. I love that
so
line.
This is an idea that's been kind of concluded. But to my surprise, Ken actually, you'll listen to what Ken says about this. If you can get onto this bus, this data bus, and you can figure out how to talk to it and give it instructions to it, because theoretically you can talk to any of the devices that's on the box, any device that is on the data bus, you can interface with.
With sufficient skill and research and funding, maybe.
Right. Okay. That's a big one. That's a big hurdle.
Yeah. And I think that's what concerned me is each layer of the Swiss cheese in this theory was a big hurdle by itself.
Right.
It's not the pilot being a bit tired. It's not the pilot miscommunicating with his co-pilot. It's not some bad weather, all contributing to a series of events that cause an airplane to, land heavily. It's a series of very significant technical hurdles, each one of which is big by itself.
Got it. I mean, I guess my response would be to say that we don't know where this plane is. And the scientists who defined the search area created a probability distribution, and it looked a little bit like a fried egg. And the further away you get from the yolk, kind of less and less likely it is to find it. And they wound up searching a really huge area, and the plane wasn't there. And so there's kind of the interesting question of like, well, how do we possibly explain this? And so I guess the exercise of me talking to you today is to address the possibility that the reason it wasn't found where the data defined the area is because the data had been tampered with. Now, obviously, that is going out on a limb, and we're trying to gauge today how unlikely it is. And you're telling me it's like somewhere in the area between impossible and just very unlikely, right? But not quite as as impossible. And I think I was telling you in an email that the entire case at this point lives in this gray space between unlikely and impossible, because they should have found the plane by now.
Yeah, absolutely. And for the victims, for their families, for the industry as a whole to be able to close and learn from this, I think it would be incredibly powerful. It's an unsolved mystery right now, and we need to find a way of solving it so we can all be even safer as a traveling public. It's possible.
Okay.
And that's my big challenge, is with sufficient resource, with sufficient skill, with sufficient incredible knowledge of the 777, its suppliers and its systems. Yeah, it's possible, but I don't think it's plausible, sadly.
So there you have it. This is a guy who really knows his stuff about cybersecurity and hacking, and he thinks that this idea is plausible. It's possible. He doesn't think it happened. He thinks it's just would require so much work, so much sophistication, that he does not think it probably happened. But, as I said to him, and I've said many times before, there are no good, simple answers to what happened to this plane. The entire case of MH370 resides in this gray area between implausible and impossible. So I was very encouraged to hear him say this.
Yeah, and again, he's speaking on his topic, just like Jim, our marine biologist, is speaking on his topic. And when you look at these things in an isolated sort of way, implausible is generous for how weird this is. But if you look at the totality of it, then all these extremely implausible things kind of roll up into something that perhaps is a little bit more likely.
Yeah, I mean, it's almost like the implausibilities kind of line up, right?
Yeah.
So if you're looking at these at the marine life, and you had and all you know about the Inmarsat data is that it conclusively tells you that the plane went south, and every reasonable person is telling you the plane had to go south, then you look at this marine life and you're like, well, I can't explain it, but it must make sense somehow. And conversely, if you're looking at this Inmarsat data, and all you know is that there's this debris has washed up, and every reasonable person says it has to have come from the plane, then you think, well, there's this Inmarsat data. It's weird that this vulnerability exists, which is so few planes have this vulnerability. It's only when you take these two pieces of information together that it all starts to add up.
So we're 22 episodes into this series, and we're almost done with this specific episode. So I think it's time for me to tell you what I think happened to this plane. Here's my theory after everything we've learned, especially including today. All right, this plane, I believe this plane was taken by hijackers. I believe this plane was taken by Russian hijackers, because they are the only country that has the sophistication to pull off something as grandiose and sophisticated as what we're proposing. I think that they did anticipate the BFO data being something that Inmarsat would look at. And if they would have been wrong and they wouldn't have looked at it, they just would have they would have done a better job of covering their tracks than they needed to, because everyone said, well, Inmarsat hadn't even invented the concept of looking at BFO data. Well, the former KGBs, they're pretty smart and they're very good hackers. I don't think that the plane was flown from the electronics bay, at least not for very long. I believe that when the Russian hijackers went down there, they did that primarily to turn off the oxygen supply, and using their scuba diving knowledge and with the portable oxygen canisters had enough oxygen to disengage the SDU, and also to maybe institute one severe turn. But at that point, when they turned off that fuse bus that also controlled the cockpit door, that should have been unlocked, and at that point their magical device could have been plugged in from the cockpit, as our expert says, how there are these actual inputs on these planes, and this was much less sophisticated time. I mean, these were some pretty antiquated by today's standards systems that had not yet been exploited, and we just showed how they can actually be done.
Yeah, that's a really excellent point, Andy. We should draw a line under that thing that Ken said, which is that this plane was built in the 90s. Like
Mm-hmm.
the plane was in 2014, but the equipment is older, much older than that. So yeah, that's a really great point. I'm sorry, I didn't mean to interrupt you, but I just
Nope,
wanted to
that's
draw
about.
light
I
to
mean,
that.
I pretty much think that everything else we've talked about checks out, and we're going to get into more detail about that in subsequent episodes. But I think the kicker here is that this plane was hijackable and was hackable by people who had enough resources, enough motivation, and enough knowledge and money to pull it off. And from everything I've seen over 22 episodes, that is the most logical explanation I can come up with.
I appreciate that. I think that's a very lucid take. I think we really made news here today, Andy. I think what we've brought to our listeners is something that I think would blow a lot of people's minds, which is that not only has some random journalist proposed an idea that this BFO could be spoofed,
Yeah.
but an actual cybersecurity professional is saying yes, this vulnerability did exist. He doesn't think it happened, but if you're gonna, I think it needs to be included in the menu of possibilities. And if the Australian authorities would acknowledge that, even if they didn't think it happened, it is a possibility that needs to be considered, that would be epical.
I hope it happens. And the
Me
only way
too.
it's going to happen is we're going to continue to plug away at this. And you viewers and you listeners are helping us by your support. So
Yeah.
that is, again, why you should be liking and
Yeah.
subscribing.